So now we can talk about the idea of a vertical asymptote. You've probably seen these before when you talk about rational functions. If your function approaches infinity or negative infinity, as x approaches c from the right or the left, then the line x equals c is a vertical asymptote of the graph of f. So if you're looking for a vertical asymptote, right here, here's our vertical asymptote. It's x equals c. So let's look at an example where we find the vertical asymptote. Let's say my function h of x is 1 over 2 times x plus 1. So here I have a rational function. The numerator is constant, so I just need to look at the denominator. And what makes the denominator 0? Well, if I divide by 2, I'll see x equals negative 1. That's what makes the denominator 0. Nothing makes the numerator 0. So this right here, x equals negative 1, this is my vertical asymptote. Let's look at another one. Let's look at the function x squared plus 1 over x squared minus 1. Now you do probably want to factor everything as much as you can. I can't factor the numerator, but I can factor the denominator. It's a difference of squares, so I can factor it as x plus 1 and x minus 1. So I'm going to look what makes the denominator 0. I'm looking at the denominator. There are two values that make the denominator 0. X equals 1 or x equals negative 1. So then you need to look at the numerator. What makes the numerator 0? The numerator is never 0. It's always at least 1. So in this case, I have two vertical asymptotes. And those two vertical asymptotes are x equals 1 and x equals negative 1. All right, so let's look at one more problem. We're going to step it up a notch. I want you to determine all vertical asymptotes of the function h of x, which will be x squared plus 2x minus 8 over x squared minus 4. So the first thing we're going to do is we're going to take our function and we're going to factor the numerator and denominator. So the denominator is the difference of squares again, so you can factor x minus 2x plus 2, and the numerator will factor into x plus 4, x minus 2. Now here, if I look, I can see that two things are identical in the numerator and denominator. An x minus 2 and an x minus 2. So as long as I'm not looking at x equals 2, I can cancel those away, provided x is not 2. So now that I've simplified this down, I can now ask myself, what makes the denominator 0? The only thing that makes the denominator 0 is x equals -2. The numerator is not 0 there, so this is my only vertical asymptote. And if you wanted to verify this, you could graph the function, and you would see that if you take the limit as x approaches -2 from the left, you would get -infinity. If you look at the right-hand limit, you would get infinity for that. So this is a vertical asymptote, and it's the only vertical asymptote that we have.